All right, so if you're going to be looking for equivalent ratios here, and for this one, you could actually divide both by 2. So we could actually say this is the same as 3 to 2.5. If we divide both 6 and 5 by 2, we could have also doubled them. So if we double 6, that's 12. And if we double 5, that's 10. Or we could also multiply both by 10, and that's 60 to 50. So those are all equivalent ratios. So any of those plus infinite others would be great. For this one, we could double both 12 and 2, and so then that would be 24 to 2. We could also multiply them by 5. 5 times 12 is 60 to 5. Or we could go multiply both by 100. So that'd be 1200 to 100. And those are all equivalent ratios to 12 to 1. Now for this one, same thing. Multiply both by 2, so 2 to 10, which is the same as 3 to 15. So there's plenty there. One that I want to point out right off the bat here is both 25 and 40 are divisible by 5. So if we're going to reduce this, this would be 5 to 8, because 25 divided by 5 is 5. 40 divided by 5 is 8. If we're going to then go double this one, so 2 times 5 is 10. 2 times 8 is 16. Those are all equivalent ratios as well. If we're going to reduce this one, 3 is a common factor of 3 and 12. So 3 divided by itself is 1. 12 divided by 3 is 4. And that's the same as 2/8. And so there's others. You could put it, we could have had 30 over 120, etc. If we're going to reduce this one, 2 goes into both 28 and 10. So that would be 14 over 5. You could have also put 280 over 100, plus dozens others, infinite others. If we're going to reduce this one, this is going to be 3 to 2, because both 9 and 6 are divisible by 3. We could have also put 18 to 12 if you doubled both 9 and 6. And for this one, 35 and 14 both have a common factor of 7. So then if you divide 35 by 7, that's 5, and 14 divided by 7 is 2. So in lowest terms, it's 5 over 2. We could have said 10 over 4, 20 over 8, etc. So there's all kinds of common equivalent fractions or equivalent ratios for each of these.